How's it going, ladies and gentlemen? My name is Kaz, and your days of being depressed because your entire cheat relies on HazeDumper are soon to be over. If you watch this video, you will no longer need to turn to hard drugs every single time CSGO updates while you wait for HazeDumper, because we're going to make something called a Netvar Manager, which will get us the latest offsets every single time you inject. But first of all, what on earth is a Netvar? Netvars, also known as networked variables, are a series of variables that hold entity information. Things like positions, health, names, and all of that fun stuff. Every entity in CSGO has them, and they are stored in a list. We are going to take advantage of this because we are dirty hackers by looping through these lists and storing the offsets for ourselves. From there, we can use them as we like, and you will never have to update offsets again. But before we do that, if you want to help out the channel and get access to all the source code used in my videos, check out my Patreon down below. I also have a Discord server where we talk shit and occasionally help people, so join us over there if you want to hang out. And finally, it doesn't hurt to drop a like and subscribe for more content. Anyway, with the boring shit out the way, let's get into the code. Alright, so welcome to the first part of the video. In this part, we're going to set up our project. Now, I just want to say, if you've never made an internal cheat before, then I suggest you check out my video on creating your first internal hack. That'll explain everything about internals for you and will get the ball rolling. Anyway, with that out of the way, we need to go ahead and set up some properties. So I'm over here in an empty Visual Studio 2022 project using C++, and we're going to come to the top here, and we're going to change from debug to release, and then we're going to change from x64 to x86. Next, we're going to right click on our solution, go to properties, and we're going to go ahead and change the configuration type to dynamic link library. We're going to change the language standard to C++20, and then we're going to come over here to advanced. We're going to change the character set to multibyte, and finally we're going to come over here to linker system, and we're going to change the subsystem from console to Windows. Go ahead and apply. Alright, now we can go ahead and make our main file. It's going to hold our entry point, so let's do that quickly. We make a source file called main. First things first, we're going to go ahead and define Win32 lean and mean, and then we're going to go ahead and include the Windows SDK, and this will allow us to create our entry point. Now, as I said, if you know nothing about DllMain and the DLL entry point, then go check out my other video. But once you come back, let's get into it. So that's going to be a bool WinAPI DllMain, and it's going to take an H module instance. It's going to take a D word reason, and finally it's going to take an LP void, and that's going to be called reserve. If I could spell it right, there we go. Now, DllMain returns true, so let's go ahead and do that. And as per usual, we're going to check why DllMain is getting called. So if reason is equal to DLL process attach, go ahead and make our if block. First thing we're going to go ahead and do is disable the thread library calls. So disable thread library and calls, and we're going to pass in the instance. Next, we're going to need to create our hack thread. So to do that, we're actually going to need a function for our hack thread to run. So we're just going to go void hack thread, and what this is going to take is an H module instance, the same as in DllMain over here, and yeah, we can just leave this empty for now, and we can go ahead and create our thread. So const auto thread is going to be equal to create thread, so we're going to use the Windows API to create this thread. The first parameter can be null pointer, next one's going to be 0, next one is going to be a reinterpret cast, and we're going to cast to an LP thread start routine, and what we're going to cast is actually our hack thread function over here, so we're going to paste that in there. The parameter that we're going to pass to this function, as you can see, it takes a parameter, is going to be the instance of our DLL. So go ahead and paste that in there. The next parameter can be a 0, and finally the last one is a null pointer. Last but not least, for our DllMain is we are going to check if the thread was made, and if it was, we're going to go ahead and close the handle to the thread because we no longer need those resources. We aren't going to be doing anything with the thread. Alright, cool. That just about wraps up our entry point and everything like that. Now we're going to need interfaces to accomplish a Netvar Manager. So if you haven't seen my video on creating an interface manager, I highly suggest you do that because you are going to need the get interface function. I have the function over here. This is literally copy pasted from my previous video. It looks something like this, but once again, go watch my previous video and go ahead and get that function because we are going to need it. But now we're going to go over here to header files, and we're going to create an interfaces.h. So let's go ahead and do that. We're also going to need to make an entity class. So we're going to go ahead and add a new header file, and we're going to call that entity. Now, in our entity class, we're just going to make it empty for now. This is where our Netvar Manager is basically going to go, but we don't have that yet. We haven't made it yet, so we're just going to make this empty. Class C entity, your brackets, and public, and it's just going to be empty for now. But with that, we can now get our interfaces. Now, we're going to need to include that empty entity class that we made just for now. This is what the iClient entity list interface is going to look like. Essentially, I just haven't named these virtual functions. I'm just calling them unused for the sake of simplicity in this video. video, but what we need is the fourth virtual function. And as you can see here, it returns a C entity pointer, which is this empty class that we made. But what is important is that this has to be the fourth virtual function. So if we had to index these, it would be 0, 1, 2, and then this is the third one in the index, or the fourth function. But it doesn't end here. We're going to need one more interface, and that's going to be the client interface. Now the iClient interface, it's actually iBase client DLL, but we're just going to shorten it to iClient. It's going to be roughly the same thing, except we are going to have 8 empty virtual functions here. Once again, if you understand how virtual functions work, you'll know why I'm doing this. If you don't, this might be a little bit confusing, but don't worry about it. As you can see here, we have something that returns a client class, and for now we have that empty. And that's because in the next part of this video, we are going to go ahead and define that. But for now, what we need to do is make the global pointers that we are going to access these interfaces from. We can go ahead and do that like so. So we're going to make an inline iEntityList pointer. We're going to call that entity list, and we're just going to initialize it to a null pointer. And next we're going to make an inline iClient pointer, and we're just going to call that client, oh, I can't type client, and we're just going to set that to a null pointer too. Next, we actually need to define what a client class is. And client class is basically a class out of the data table that we're going to be using. So we're going to come over here to header files, and we're going to add a new header file, and that's going to be DataTable. Now, this is going to be a couple structures, and I don't expect you to type it all out. So I'm going to have a link to this paste bin in the description below, not that one, this one. And what we're going to go ahead and do is come over here to raw paste data. We're going to Control A, Control C, Control A, Control C, and we're going to go ahead and paste this in here. Now, if everything is all right, you shouldn't have any errors. Over here, I've included the link in the source SDK to where you can find all of this stuff. But basically, this is a linked list that the source engine uses to store all of the offsets for all of the important variables that we're going to be using. But if you look in here, I've also defined client class in here. So we're going to need to come back to interfaces, and we're going to need to include our DataTable.h. And that sorts out our interfaces. Now, the last thing we're going to need before we actually get into the Netvar Manager is we're going to need to get some form of a hashing function. So we're going to make a header file called fnv, and we're going to make an fnv hashing namespace. Once again, I'm not going to expect you to type this out. I'll have a link to the paste bin down below. You're going to come over here. You're going to copy all of this. Actually, it's better if you do it in the raw data section over here. And we're going to come back to our fnv file, and we're going to go ahead and paste this in here. Now, what hashing does is it takes a string and it turns the string into a unique set of numbers. And the reason we do this is because computers are pretty shit at dealing with actual text. They are really, really good at dealing with numbers. So what we're going to do is we're going to change the text to numbers so that it's very efficient. If you want to know more about FNV hashing, just go ahead and Google it. It's got some fucking weird name. Who cares? Anyway, just know that you need this. Alright, with all of the boilerplate shit out the way, we can actually get into making our Netvar Manager. So to do that, we're going to need the last two files, which is going to be a header file, and that is going to be Netvar.h. And in our source files, we're going to make a Netvar.cpp. So Netvar. And of course, in our Netvar.cpp, we're going to go ahead and include Netvar.h. So how this is all going to work is we're going to make a function called setupNetvars, and what this is going to do is it is going to recursively loop through this data table stuff that we made over here because it actually exists in the game. And the address, how we're going to get the address of this stuff is from, if we look in interfaces over here, this virtual function over here, this is index 7, so the 8th virtual function of the iBase client DLL interface is going to return a pointer to the first class in the hierarchy. We're going to use that to loop through the linked list, and what we're going to do is we're actually going to dump all of the interfaces. Of course, we're going to hash them so that we can use numbers instead of letters, as I said earlier, and we're going to store them in a map. If you don't know what a map is, go learn C++ or just search up a standard map. We're going to use a map, and we're going to store the interfaces in a map, and then we're going to make a nice little macro to access them. So let's get started with that. First of all, we're going to need to go ahead and include our fnv hashing function, so include fnv. Next, we're going to need access to the data table, so include data table, and we can go ahead and make our void setupNetvars function. That's going to take no parameters, and it's just going to look like that. Next, we're going to make the function that we're going to use to recursively dump these netvars to get the offsets. So that's going to look something like this. We're going to make a void function. We're going to call it dump. This dump function is going to take 3 parameters. So the first one's going to be a const char pointer, and we're going to call that base class. This is going to be the name of the base class. The next parameter that this function is going to take is actually going to be a receive table pointer, and we're going to call that table. And finally, it is going to take an std uint32 underscore t, and this is going to be offset, and we're going to set this to 0 as a default parameter. Now, the last thing we need to do that is Netvar related is we actually need to make the map that's going to store the offsets. We're going to go ahead and make an inline std unordered map, and that is going to take 2 unsigned int32s. So that's going to be std uint32 underscore t and std uint32 underscore t, just like that. And what we're going to do is we're going to call this netvars. Now, once again, if you don't know what a map is, it's basically a linked list like a vector, except it takes a key and it takes a value. So if you give it a specific number, it will return whatever value is stored at that number. In this case, we're going to be storing the hashed netvar name. So it's going to be like be spotted, or it's going to be health, and it's going to return. Holy shit, a cockroach just fucking touched my fucking foot. That's disgusting. Anyway, so what I was saying is you're going to give it a hashed netvar name as a key, and that's going to return the offset of the netvar as an int. And then we can use that offset in our entity class over here to then access literally any offset you want. And this is all going to get dumped when you inject, so you're never going to need to update offsets again. That's pretty cool. Now, the last thing we need to do in our Netvar.h over here is we're going to make a macro to make creating these netvars a little bit easier. So we're going to hashtag find, and we're going to call this netvar. And what this is going to take is a func name. It's going to take the netvar, and it's going to take the type of the netvar. And what this is going to return is a reference to the type, and the name of the function is going to be func name. And then of course we need the parentheses to declare a function. Then we can make our function body over here. Now we need all of these backslashes because we are making a macro, and if you don't know what a macro is, once again, go learn C++, not my problem. Anyway, we're going to make a static auto offset, and this is going to be equal to netvar. So what we're going to do is, as I said, we're going to access this map over here, and the key that we're going to pass in is going to be fnv-const. Very important. We're going to use a compile time hash, and what we're going to hash is the netvar, just like that. And backslash, one more line. What we're going to do is we are then going to return dereference, reinterpret cast, and we're going to pass this to a type pointer, and this is going to be an std uint32 underscore t. We're going to cast the this pointer to that plus the offset. And don't forget your semicolons. We need a backslash there, and that wraps up our netvar macro, and that wraps up our netvar.h. So one more time to go over this, we're going to call this function once. It's going to call this function, which is going to recursively dump all the netvars. All the netvars are going to be put into here. They're going to be saved. This here is going to be the offset of the netvar, and this here is going to be the name of the netvar, but it's going to be hashed. Once again, because computers are better with numbers than they are with strings. This here is a macro, and it probably doesn't make sense right now, but you'll see when we use it later why it makes life a lot easier. But this is going to take the name of the function, it's going to take the name of the netvar and what type the netvar is, and this is going to construct a function over here. And as you can see in here, we have a static offset. So this means it's going to get the offset once, and this is forever going to sit in this function, and every time we call it, all it's going to be doing is reinterpret casting this pointer, which is going to be the address of the entity pointer, to the offset, and it's going to return us that netvar. Alright, cool. So now we can move on to Netvar.cpp. Make sure you have Netvar.h included, and we can begin coding. So we're going to go ahead and include interfaces.h because we are going to need access to that client interface. Next, we're going to go ahead and include ctype.h, and we are going to need to include format. Now, because we're including format, I forgot to say, come over here to project settings, and we are going to need to use over here in general, we're going to need the latest, preview latest from C++, whatever. We're going to need the latest features to use the format library. And we're going to use the format library because it makes the code a lot cleaner. Anyway, coming back, we can go ahead and define these functions that we have in Netvar.h. So it's only two functions. We're going to go ahead and copy these two functions, come over here to Netvar.cpp. We can remove this comment, and we are going to need to define them. So create a body for them. And because we're defining this function, we no longer need this default parameter over here. So when it comes to the setup Netvar's function, the first thing we're going to do is loop through the linked list, and we can do that like so. We're going to create a for loop. We're going to create an auto client class, and this is going to be equal to client. Remember, client is that pointer that we have in interfaces.h. Of course, when we first compile our cheat, these are going to be null pointers, but in a second, we're going to go ahead and populate these with the actual interface pointers. So if you don't do that, you're just going to crash if you try and call any function from here, but don't worry about that. We're going to call get all classes. We're going to say while client class is not null. We're going to go ahead and set client class is going to be equal to client class next. Now, if you don't understand what this is doing, if we check out what type client class is over here, it's a type client class. And as you can see, each client class holds a client class pointer called next. Once again, this is a linked list. Every single one has a next, next, next all the way down the list until it's null. So this way we can loop through all of the different structures. The next thing we're going to go ahead and do is check if the table is valid. So we're going to say if client class table receive table. So we're basically checking that it's not a null pointer, and then we're going to recursive dump, just like this. So we're going to call that dump function. Of course, we haven't made it yet, but we're going to call dump. God, it sounds like I'm talking about taking a shit. Don't worry about that. Client class, and it's going to be network name. That's going to be the first parameter. Second parameter, because we need the we're going to need the receive table over here. So client class receive table, and the first offset that we're going to pass is going to be 0. Oh, made a spelling mistake there. This needs to be client class, not client. And that wraps up our setup Netvar's function. Now our dump function. So the first thing we're going to do is loop through the table's props, and we can do that with a for loop. So we're going to go for auto I is going to be equal to 0, while I is smaller than table, and we're going to use props count. We're going to increment I. We're then going to go ahead and get the prop. So const auto prop is going to be equal to the address of table and props. So props is an array. So we're going to get the address. Oh, I accidentally duplicated the line there. We're going to get the address of the current prop in this index of the array. Now we need to actually make sure that prop is valid. So if exclamation mark prop, or we're going to use is digit prop var name, and we're going to check if the first, let's continue over here. We're basically going to check if the first character in the name of the prop is a digit, and why that is because there are props that have digits as first names, and we aren't interested in those. Those are weird, those are ugly, they need to be ostracized. Next, we're going to make sure that we aren't going to be storing a base class, because base classes hold other props, and we don't want to store the base class. We want to actually store the props themselves. So we're going to do that like so. If fnv hash, so we're going to hash prop var name is equal to fnv hash const, and we're going to hash const base class, just like that. So if that's true, we're going to go ahead and continue. Now, of course, you could use string compare, stir comp over here if you wanted, but we're going to use hashes because we're cool. Now we need to do some checks. We need to make sure that we actually do want to store this prop, or if it has more member props, we're going to go ahead and dump those ones too. So we can do that like so. If prop, and we're going to check the type of the prop. So if prop receive type is equal to, and we're going to use this enum that we have here, send prop type data table. So we're going to make sure it is a data table, and we're going to make sure that the data table that we're accessing over here is not a null pointer, and we are going to make sure that prop going to access the data table once again and table name, and we're going to check the first character of the table name is equal to D. And then we're going to check if the prop data table first character of the table name is equal to a D, because basically the data tables they start with DT underscore, and we're not interested in that. We actually want the like CS player. We actually want the class that they were a part of. We don't want DT player, whatever crap that is. So if this is the case, it means that there are more props to dump, and that's where the recursive aspect of this comes in. So we're going to go ahead and recursively dump. We're going to call this function from within itself. The only difference is that we are going to, of course, this is not going to be client. This is going to be base class over here. And this is going to be prop data table, and we are going to pass in offset. So the offset of that we passed in, and we're going to add the offset of the prop. Okay, cool. So as I said, that's going to recursively loop through the linked list, and it's going to go ahead and get all of our netvars. Now, the last thing we need to do is actually construct the netvar that we want to store. We then need to hash it, and then we need to store it. So const auto netvar name is going to be equal to, and as I said, we're going to use format. So std format. Make sure you are using the preview features. And what we're going to do is we're going to make these curly braces with an arrow in between them, and the first curly brace we're going to populate with the name of the base class, and the second curly brace is going to be the name of the actual netvar that we want. So prop, I don't know what it's called, var name, there we go. And last but not least, we need to store it in our netvar map. So netvars, and the key that we're going to use is going to be fnv hash. What we're going to do is we're going to hash the netvar name, and be careful, we need to pass it in as a c underscore str, as a c string, and we're going to set that to the offset of the prop. So that's going to be offset plus prop and offset, just like that. And that wraps up our Netvar Manager. Now we actually need to use it. So coming down over here to main.cpp, the first thing we're going to go ahead and do is actually populate these Netvar offsets. Once again, we're going to be using this get interface function that I made in my previous videos, so go check that out if you need that function. Of course, we're going to need to come over here, and we're going to need to actually include interfaces.h. And then we will be able to get the interfaces like this. We're going to get the client interface, which is vclient18 and client.dll. And we're going to use the entity list interface so that we can make a radar hack using our new Netvar Manager. Of course, as I said earlier, we're going to need to call setup netvars just once. So setup netvars, I'm being an idiot. Okay, before we go any further, we're going to need to come over here to our entity class. What we're going to do is we're now going to go ahead and include our Netvar Manager. So include netvar, and we're going to add one netvar in here just for an example. How you add a netvar to this is we go netvar, the name of the function. So we're going to want to call it spotted, the name of the netvar. The name of the netvar that we're going to be using is going to be c-base entity, and then the arrow, and then m_b spotted. And the type of b spotted is a bool, because as we can see over here, it is bool spotted. Let's go ahead and save that. And if you hover over here, it'll show you what function it makes. It makes a function called spotted that returns a bool reference, and it's going to get the offset of c-base entity mb spotted, and it's going to return the actual address. It's going to return a reference to the netvar in the game. So that's pretty fucking cool. Now what we need to do is come over here to interfaces. We already have that included. I was just making sure there. And coming over here to main, we can now go ahead and set up our netvars. So setup netvars, go ahead and call that function. Now we're going to go ahead and make an if exclamation mark get async key state. And I'm going to use vk_end. So if you click end, it's going to break us out of this while loop. I don't know why I made it an if statement. While, and we're going to make the body of this function. And outside of this, of course, we're going to do the usual and free library and exit thread. We're going to pass in the instance, and we are going to use error code 0. Now in here, we are going to make a radar hack with the Netvar Manager and the offsets that we have just made. So I'm going to show you guys how to do that. First things first, we're going to make a for loop, and we're going to say for auto I is equal to 1. So while I is smaller than 64, smaller than or equal to 64, because we want to loop with the players, we're going to go ahead and increment I. Now we can go ahead and get the entity. So const auto entity is, oh, I forgot auto over here. Const auto entity is going to be equal to entity list. And we're going to call a function, the only function that we're allowed to call, get client entity, and that takes the index. Now remember, if you haven't watched my previous video, this is actually a game function that we're going to be calling. We haven't defined this function. If we come here, it's empty. It's literally set to 0. But because we have this pointer set to the right address through our get interface function, this allows us to call the game's functions. Next, we need to make sure that our entity is valid. So if exclamation mark entity, we're going to go ahead and skip this guy. And if the entity is valid, it means that it's a player. And now what you can do is you can access the netvar. So if we use the arrow operator on this pointer, you can see we have a function here called spotted. If we call that, it returns a reference. So this means we can literally set what it returns to true. And this means that what we're going to do is we're going to be setting the B spotted offset to true, essentially using the spotted offset like if we were to use haze dumper. If we go over here, we can see the, I'm over here in the haze dumper repository. We can see we have m_b spotted 0x93d. We're basically doing the exact same thing, except we're going to get that offset when we inject. So even if it changes, we're always going to have the most up-to-date offset by using our Netvar Manager. So you'll see how this works now. Anyway, we're going to go ahead and build, and let's hope that this works. So I'm going to hop into the game, and I'll catch you guys there. Alright, so I'm in game over here. I'm in my release folder. As we can see, we have Netvar Manager.dll. I'm using Xenos again. I have the DLL added. I have CSGO.exe, and I'm going to go ahead and click inject. We've injected, and if we check out the radar at the top there, they're all spotted. Let's let our whole team die because bots are shit. And as we can see, we can still see them on the radar, even though we haven't spotted them. And that's because we have a fully functional radar hack using interfaces and a Netvar Manager, which means that we're getting the latest offsets every single time. Of course, you'd probably want to check if they're dormant. You'd want to check if the player is alive too and everything like that. Also want to check if they are an enemy, but this is just supposed to be a very basic tutorial. Anyway, I hope you guys enjoyed that video. This is a very, 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 very useful thing. You need this in any decent cheat that you are trying to make. This combined with an interface manager are the two fundamental basics to making a decent internal CSGO hack. If you have those two things, you can basically do anything. Triggerbot, chams, ESP, everything like that. And we are going to go ahead and include, we're going to go ahead and continue making proper features in the future. So look forward to big changes on this channel, big videos incoming. Remember, if you enjoyed this video, be sure to drop a like and subscribe. And if you want all the source code used in all my videos, and including this one, you don't feel like typing out, check out my Patreon down below. I have a Discord server, and thank you to my current patrons. Love you guys are sexy, and I will check you guys in the next video. Cheers and peace out. Mwah.